Arc Junkies presents Weld Wednesday with AWS. Brought to you by the American Welding Society. And now your host, Jason Becker.
All right, Sam, what's going on, man?
Oh, not too much. Just finished up work for the day and excited to get into this.
Yeah, man, I appreciate you coming out on the podcast to talk about your experience, when it comes to weld engineering, automation, welding, CWI work. I mean, you've got like a litany of stuff that you're involved in, so I kind of wanted to pick your brain on some of this stuff.
Sure. Well, thanks for having me, and I'm ready.
All right. So when did you get started in welding? You went to Purdue to get your degree, correct?
I did, but that's not how I started welding. I got started in welding actually way back in like junior year of high school. It's kind of funny. I'm not the most academically inclined individual, and I think my mom recognized that. I was going through high school, and my senior year, my dad runs a small business. He wanted to learn how to weld, and so my mom kind of pushed me and said, "Hey, why don't you take some welding classes with your dad?" So my dad and I signed up for these welding classes in the back of this really tiny local welding supply store in downtown Indianapolis. They had this kind of dark, dingy welding lab shoved in the back corner of it. And so I took welding classes there, and that's where I was first introduced to welding. Actually got certified that summer in shielded metal arc welding. I had a 3G, 4G certification, and just fell in love with welding. It was like a fish to water. I loved it. And so after that, I actually chose to go to community college for 2 years and got my associate's degree in welding technology, and went straight out into the workforce. Straight out as a welder, got a job in downtown Indianapolis, which is where I'm from, as a welder, doing production welding at just a custom manufacturing kind of job shop company. And it was a great company to work for, a great start. And they kind of recognized I had a real passion for welding and let me, through a course of several events, kind of move my way up into a robot programmer position. That's where I got exposed to robots and welding automation, and then sent me back to school. And that's how I kind of ended up with being a welding engineer and where my career started.
Wow. So prior to your sophomore year, you had no introduction to welding, no inclination to do it. You just knew that academics wasn't for you, and your mom kind of identified that and said, "Hey, go try working with your hands."
Yep.
What a crazy concept.
I'm terrible at math, which is funny being an engineer now.
I was going to say, how do you squeak by an engineering school with being horrible at math?
I think it was less of me being terrible at it and me just having a general disdain for math. And so I make do.
Well, I mean, it's like I've said many times in the podcast before, once you find a way to make it relevant, math doesn't suck anymore. It's like, cool. Like I just figured out the answer that I needed to, finish the angle on this part, or, do a cut list or pull the dimensions on this, that, and the other. So once you realize the value of the math and how to utilize it, it's like, oh man, it's just another tool in your toolbox. But it's the theory behind it, and somebody's like, oh, how many gallons of gas is it going to take to get, this car from point A to point B with, X amount of miles per gallon and an uphill slope of, 17 degrees. And it's like, I don't know. When am I going to use that? But if you make it practical, if you show me a reason why I need to learn something, I'll learn it. Same thing with like chemistry and metallurgy, math, all that stuff. Once it becomes relevant, then it makes sense to me. Then I start digging deeper. It's like, oh, cool. This math formula, to find the center of a circle is really cool. What other, things are there? The Pythagorean theorem. Oh, cool. Now I can do stairs and handrails. So just having that at your disposal, I think it makes you a much better welder. And for most people, they're not good academically. It's hard to make that correlation. It's hard to make that relation. But once you do, then you start diving a little bit deeper. You start memorizing this stuff. You start writing it down. My buddy Weston's got this book, Shiner's Practical Math, and it's just filled with formulas for welding and fabrication. I mean, it's an awesome little book to have in your arsenal. But once you realize where you can use it at, I mean, it's a necessity.
Yeah, and I think that's really what happened with me too. Once I started working as a welder and got out on the shop floor and started to have to use geometry and trigonometry to figure out how to tack and fit parts together, it really just clicked and started to make a lot of sense. Um,
So, what made you continue on down the college route, or to start on the college route, having been exposed to welding and been working in the field?
Yeah, really, it was kind of just coincidence. I was given some opportunities there at the company I worked for in Indianapolis to move up, and once I started robot programming and really started getting more into the uh, engineering and highly technical side of things, started doing work with 3D modeling and FEA. I kind of just decided, hey, I think I want to learn more about this. I need to backfill some of the actual technical education side of it. And they happen to have a program where they paid for my degree and chose to move forward with that.
Yeah, I mean, why
And I
not
think
take a chance?
a lot of companies have programs out there that aren't necessarily advertised too. And so I think there's a lot of opportunity for welders and skilled tradespeople who maybe have the desire to get that higher education to go out and do that for practically for free. And they just don't know that the opportunities are available.
Yeah, I know there's a lot of big companies. There's a couple here in Central Florida that I've sent students to, and like I had the kind of inside scoop because I talked to the folks with HR and some of the supervisors, and they said, "Hey, we've got a tuition reimbursement program. So if somebody's here, if they can work and go to college at the same time, we'll give them 100% reimbursement while they're attending school. And then so you practically pay $0 for your education in the long run. Up front, you got to pay for it, but I mean, you've got to show that you're dedicated." You turn in your grades and your receipt for the tuition and all that stuff, and you get reimbursed. A lot of companies, they want to support that fire. They want to nurture that flame just because it's a greater pool to, start recruiting from. If I want to recruit somebody for a supervisor in the shop, why would I go hire somebody or put an ad in the paper or up on Indeed or LinkedIn or whatever when I can say, hey, this guy over here, this gal over here, they're currently working here. They know the system inside and out. They're doing the work. They're familiar with the company, and they're furthering their education. Why not hire them as to fill this supervisory role?
Exactly, and that's also how I ended up getting my CWI. Same company, they recognized that I had the drive and the passion and the ability to learn, and so they came to me and they said, "Hey, Sam, I think you've got the aptitude for this. You're qualified to go get this certification. We're going to spend a little bit of time doing some training with you and having you work with our CWIs here on the shop floor." And ended up sending me to an AWS seminar, and I was able to pass the CWI on the first time, which
nice.
I've heard is kind of a miracle.
That's a difficult test. What do you think of the test overall?
It's a hard test.
It is.
I don't want to take it again.
No, keep your stuff current. I've actually, I used to proctor for the exam, and like some of the guys that would come in there to retake the test are like, if you have your CWI, whatever you do, don't let it lapse. Whether you think you're not going to need it again, pay the fees, keep up with the continuity, just because if you let it lapse and you have to, get your CWI again, you got to go through that entire process. So whether, I might get into underwater basket weaving next year, but you know what? I'm still going to maintain my CWI status because if things don't work out with the baskets, I'm jumping right back on my card.
Absolutely. Absolutely.
Now, how did they go about preparing you at work to take that exam? You said you were working with some of the other CWIs because a lot of people that go take that exam, they've never had any practical experience doing inspection work or working with any of the documents.
Sure. So I think I was a little bit fortunate in that case. By the time I got to taking the CWI exam, I had already been working as part of our welding engineering department. Being in contract manufacturing, we did a lot of work for the military, a lot of work for some aerospace companies. So I was really used to working with a lot of different welding codes, EN standards, ISO standards, NAVC, a lot of work to D11. So I'd had this general exposure to a lot of welding codes. And because of that type of work, we had, I think, 5 or 6 on staff CWIs that just full time served as welding inspectors. And they also did other non destructive testing, mag particle, PT, that kind of work. And so I was really fortunate to have exposure to the codes and writing welding procedures and helping with forming, procedure qualification records and qualifying welders, and really had a wealth of knowledge with those welding inspectors to just be able to go ask them questions and talk to them and have them kind of bring me along and go witness inspections with them. I know not everybody has that opportunity, but for me, that was something I was really fortunate to have.
Yeah, I remember when I went to go take mine, I knew a lot of other CWIs, and the only exposure I'd actually had to doing like the hands-on practical is grading my students, pieces, the work that they were doing. They'd submit something, and I'd look at it, I'd check it with a fillet weld gauge, or start using the weld reinforcement gauges, like all the stuff, just doing visual examination. But nobody ever told me if I was right or wrong. I didn't have anybody to fall back on. I mean, of course, I had I've got a bunch of CWIs in my contact list. I can always call up and say, hey, what's this mean? Or, how do I get to this conclusion? Or, whatever. So when I went to go take my CWI exam, I'd at least call or text one of them every night. I'd get stuck on a question, because they give you homework to take home and everything. And I'd be like, man, I cannot figure this out. So I'd text it to one of my CWI buddies, and it's right here in the code book. And they'd give me the page number and, the clause and all that good stuff. Oh, okay. Yeah, I don't know how I missed that one.
Yeah, and one thing that I had the ability to do was, both as when I worked as a welder and when I started working in engineering, of being able to just tag along with our welding inspectors as they went out to the shop floor and went to go inspect work, or sometimes even my own work, and being able to just ask them questions of, hey, I see you marked this spot up. What did I do right or wrong? What do I need to do to fix this? Or why is this, a little bit of undercut not acceptable? And being able to ask those kind of questions and work with those CWIs really had a big impact on my ability to learn and have that kind of hands-on exposure.
Yeah, I've got a buddy down here that he does primarily in-field inspections. I kind of focus in the realm of welder certification, welder qualification, procedure development, and that's an area that he's not very familiar with. So we kind of want to job shadow each other at some point when our schedules calm down, to where I can go out in the field and just kind of like a ride along, just go see what he's inspecting, how he's inspecting it, checking the code, all that good stuff. And then he wants to come in and witness how, a weld test is supposed to be conducted. So I think it'd be kind of neat to kind of cross train in those different areas.
Yeah, that's really neat. And, it's funny to me talking to different CWIs, because we do such vastly different work sometimes. You have CWIs that they go out and they inspect pipeline all day, every day, but they never deal with procedure qualification.
Yep.
You have other CWIs that all they do are qualify procedures. I kind of fit in this weird in between where a lot of my work has to do with welding procedure qualification. But we also have this kind of arm or branch of our department that has oversight over shop floor inspection and in-process inspection. So I kind of get a little bit of both worlds.
That's awesome to be able to switch back and forth. I mean, it kind of makes you a more well-rounded welder and inspector at the same time.
For sure.
I think getting my CWI has actually made me a better welder. Once you start understanding a lot more of the science that goes into the welding, you get a deeper understanding of how to avoid these mistakes or correct them while you're doing them, like when you're actually physically doing the work.
Absolutely. And that's one thing we try to do at Vermeer with our weld training program, is really focus on teaching our new welders what weld defects look like, but also what the causes of weld defects are. And what, whether it's work angle or torch angle or your contact tip to work distance, what causes that weld defect and why that weld defect is so detrimental. We see it every day of, hey, that's just a little bit of undercut. Well, yeah, it is just a little bit undercut. Maybe we seem a little nitpicky, but that undercut can have a huge impact on fatigue life And when our equipment is going out into the field and our customers are using it, if we have a premature failure, it can cause a lot of problems.
Yeah. Now, what type of work are you all doing at Vermeer?
Yeah, so not sure how much you know about Vermeer. Vermeer is headquartered here in Pella, Iowa. We're a real small town of about 10,000, and Vermeer has grown through the years. I think we're close to 3,000, 3,500 employees just here in our Pella location. And we manufacture a lot of agricultural forage equipment, as well as heavy industrial equipment such as horizontal directional drills for utility installations. You might see for putting in fiber optic cables or gas pipelines. And then we also manufacture recycling and wood grinding products. So your typical brush chippers and tub grinders. We also do some surface mining equipment, some trenchers, a little bit of everything. We're very well diversified.
Okay, yeah, I've seen your logo on a bunch of stuff. We were actually dealing with a company down here in a place called Okahumpka. It's old Indian name, but it was a company called Vactron, and that's exactly what they did. It was like horizontal drilling or drilling up underneath the road, and they would hire a lot of our students. They were a great company to work with. I worked out a deal with like one of their, I don't know if he was a manager or supervisor, but I was like, hey, if you have like small parts and widgets and stuff and a set of blueprints, if you want to drop them off and I can have my students weld them, you can have your inspectors inspect them, and you can do whatever you want with them. But I wanted to incorporate project-based learning into my program. And so we kind of had that deal. They actually dropped off a couple pallets of parts with a set of blueprints. We'd go through and I'd show my students exactly, okay, we've got 10 of these widgets here to make. Let's go ahead and we're going to make a fixture, so we can slap all the parts in, clamp everything down, tack it all up, and then we can pull it out and weld it. And, you get weld access all the way around. So it was a win-win for the company as well as the program, because they would get free parts. And if the parts got rejected, they were like, hey, no harm, no foul. It just goes in the scrap bin or you guys can keep it. But if it passes inspection, we'll go ahead and put it in service. They ended up hiring a lot of our students to go work for them just because our students were familiar with the process and everything. So a lot of our students in the nighttime program, they'd work there during the day, and then at night they would come into class. And then when they graduated, they'd get hired on full time. But then I guess they got acquired by Vermeer.
They did, yeah.
Yeah.
I think 2 or 3 years ago.
Yep.
Yeah, that's interesting to know. I'd love to talk about that more offline and see if we can maybe kind of resurrect that type of a program.
Yeah, it was great. I think once because the guy that I was working with, he left. He's dealing with elevators now. But yeah, I think that's great for any school that you guys are close to. If you have, like I said, these are just like little latch plates or little gussets or anything like that, because they went on the back of these big tanks. Now, obviously, my students weren't welding up the tanks. They had sub-arc and everything set up at their facility to do all that. But it was just like some of the accessory holders, that hold the pipes and hoses and all that stuff, all the attachments. So it wasn't like really critical. The welds were, but, the parts weren't critical to the life cycle of the piece of equipment.
Sure. Yeah, that's really neat to hear that you guys had a program like that. I know we're definitely trying to foster those types of relationships with welding schools and training centers around our facilities. We have a number of facilities across the United States, and then we also have some international manufacturing as well.
Oh, very cool. Yeah, because you just went to, well, I guess you're part of IIW as well, right?
Yes. Yeah, I for the last 2 years have been the United States delegate to Commission 15 of the International Institute of Welding. Commission 15 is focused on design, analysis, and fabrication of welded structures. And I actually just recently, last week, was elected as the chairman of Subcommission C, which focuses just on fabrication of welded structures. Well, thank you.
That's very cool. So what do you get to do with IIW? Other than go to Singapore and participate in the conference?
Yeah, so IIW is a very interesting organization. It's really kind of the nucleus of the international welding community. It was founded shortly after the end of World War II really several nations came together and realized they had a need to cooperate jointly to advance the art and science of welding. So that's the mission of IIW, is to advance the art and science of welding. And IIW is organized into, we call them commissions in our technical working groups. And the commissions function very much like AWS committees. We focus on different topics such as, non-destructive testing or fabrication or education. And those commissions are groups of international welding experts that both help with writing international standards. So we do international standards through ISO. We're an authorized ISO certification body to write ISO standards around welding and joining processes. And then there's kind of a group of academics within IIW that are a lot of technical universities, both here in the States and internationally, that are doing a lot of research into different welding processes, different ways to improve, fatigue life or FEA analysis, or come up with better ways to design weldments. And it's really a lot of international cooperation, a lot of research. And part of the fun of my position is that, coming from industry, I get to help give feedback to that community and say, hey, these are the areas of research that would be interesting to Vermeer and to the United States as a whole.
That's really cool. And then are you incorporating automation into like your talks and your research and all that stuff as well? Because that's obviously growing here stateside. I can only imagine that it's, just going full bore, across the pond.
It is. Automation's been a very hot topic in the welding community recently, both here domestically as well as internationally. Cobots are a new thing in automation, and a lot of groups are trying to figure out, hey, what do we do with this new technology, and how does it fit into, maybe the box that we thought automation fit into? And, we're also, the education team there is trying to tackle, how do we train robot operators and robot programmers, and looking at this whole new world of automation and how we bring traditional automation as we've seen it through the 80s and 90s and early 2000s into the 2020s and into the future.
Yeah, I think the cobot kind of put the whole automation sector onto like the fast track, because I tried, that was another thing we tried with Vactron, was my buddy Josh. He was really good with the Fanuc robot. We had a Lincoln educational cell. We're like, hey, we can fixture these parts up and weld them all out. But like Josh could speak G-code and robotics, like he had a kind of a CNC background, so he understood how to like nerd out and talk to this system. And my thought process was, why can't I just grab the end of this gun and point it right where I want it to weld and say that's the start point, and then swing it over to where it needs to end and say that's where you're going to stop, and then just type in everything in between. And then years later, they came out with a cobot, and I was like, that's exactly what I was asking for. This is perfect. So they've made it welder proof. Now you push a button and you're like, hey, this is home. Here's your start point. Here's your end point. Or there's a radius in here. We can just program that into the iPad, because everybody's familiar with using touchscreen nowadays. So it's made life so much easier. So is it getting easier to train welders and robotic technicians to be able to do the work now?
I think it's funny that you mentioned that, because way back when automation first came out, some of the original robots, that's actually how you had to teach robots, through this kind of through path motion, that you actually manually moved the robot through the path and it recorded that path. And with cobots, we've kind of come full circle back to that, of manually moving the robot and teaching the robot. And I think cobots are this really interesting technology that has really kind of upset traditional automation as we've thought of it. Traditional automation, traditional robot programmers, you had to know G code, or how to navigate these just miles of code on a really complicated pendant that had a million buttons on it. And we're really confusing or really intimidating to look at and try to navigate. And the cobot came out, and here's a really simplified version of a robot that uses a tablet or a smartphone. That's something, my generation and the next generation is really familiar with. And it made it so much easier to program, to teach a robot operator, to teach programmers how to program. Some of the cobots out there just use drag and drop icons that they don't have any text hardly on the screen other than some welding parameters
Pictures.
and your speed. It's just a picture. And I think that's really made robot programming accessible to a lot of different people. And we can talk about cobots a little bit and where they kind of fit into the market. I think cobots are an interesting new technology, and there's a lot of excitement around cobots. And I get excited about cobots because I see smaller companies that maybe didn't have the capital to buy a $4 or $5 or $1 million robot cell being able to invest in automation at a much more affordable, cost-effective level. And because of the simplicity that comes with a cobot, they're also able to have their welders program it. They don't need a welding engineer. They don't need a robot programmer who has years of experience. They can have a very competent welder up and running parts in a day or two.
Yeah, it's very similar to the way that I teach welding. Like when I step into a booth with a student, I do the same thing. I'm like, okay, grab the torch, grab the MIG gun, whatever process we're working with. Okay, and I'll grab their hands. So I was like, this is where you're going to start. This is your work angle. This is your travel angle. We're going to go about 6 to 7 inches a minute. So kind of get that beat in your head. Okay, now we strike the arc and we start moving. You do the exact same thing with a cobot. You just don't hit the live arc button until you're done kind of doing like a dry run per se.
Yeah, exactly. And, that makes it so much easier. And I've preached this for years that, work angle is work angle, whether a manual welder is doing it or the robot's doing it. And so all your weld process controls are really all the same. And so I think it's really opened a lot of doors to automation there.
Yeah. Do you see a lot of welders being apprehensive to use that technology? I remember when buggos were becoming a real big thing. You can mount your torch in a track and you program it to make a run or whatever, and people are like, oh, that's not real welding. I'm not going to do, like, they're too proud to admit that, yes, it's actually welding. It's actually a little bit more technical, and you honestly have to know a little bit more about welding to get that machine to do what you need it to do.
I think we've seen small hurdles to adopting that technology. At Vermeer, we've had some struggles with automation in general, of just getting welders to want to interact with the machines. And I think a lot of that has to do with messaging. For years we've watched movies of evil robots taking over the world.
iRobot.
There's been messaging of, robots are coming for your jobs and things like that. And I think what we're starting to see is really a shift in attitude towards robotics as the younger generation gets involved in manufacturing and comes into the workforce. They're a lot more open to embracing that technology, especially technology that makes their jobs easier or makes them more productive. At Vermeer, we actually pay our robotic operators a little bit more of a premium over our typical manual welders because we recognize that additional skill and additional requirement that it takes to run that equipment.
And that also down some barriers.
Yeah, that helps eliminate some of that apprehensiveness to want to interact. And really, once we get a cobot or even a traditional robot cell up and running, and the welders realize how much more they get done, and now maybe they don't have to work overtime or they don't have to work Saturdays because we're much more productive, really helps that technology adoption.
Okay. Now, when you guys are running the cobots and the robots and all that stuff, are you running them on like the big heavy pieces of equipment, or are you just doing like the smaller stuff and then leaving some of the more complex, bigger fixtures and stuff to manual welding?
We're kind of branching out. Vermeer has a really interesting, and if you don't mind me taking a minute, Vermeer has a really interesting kind of story with automation. So being that we're in a small town, you know, Vermeer employs 3 to 4,000 people in a town of just over 10,000. We also have another large manufacturer here. Pella Windows and Doors is based here in Pella, Iowa. They're also about 4 or 5,000. So between two manufacturers, we employ essentially the whole town. And so they're really invested in their community. They really invest a lot of money and a lot of effort into the town. And my kind of take is that historically we've been apprehensive as a business to invest a lot in automation just from the perception of putting people out of work or replacing workers. We're in a pretty isolated community here in rural southeastern Iowa. But as we've seen, struggles with labor shed and just explosive business growth, we have to adopt automation. And so we've started moving more towards automation. We have an automation initiative that we've started to implement new, both traditional robot cells and cobot cells. And so we're starting to branch out to see, are these larger weldments that are more complex, that take a lot of labor, can we automate those and have our manual welders weld the easier parts to weld that aren't as labor intensive, that don't require as much fitting or work like that, to actually make their jobs easier? So we're kind of in this weird position of shifting from really easy weldments that we automate to, let's try to automate some of these more complex, difficult to weld parts.
Large scale stuff.
Yep.
Okay, that's very cool. Yeah, I seen. So I'd have to check out your facility, but do you have like a fully automated section? Because I went up to the AISC convention in Charlotte, and they had like this really cool setup. If your job is fabricating beams for construction, it's not a cool setup, but because the robots interacted with one another, like they had a CNC machine that would cut parts out. One piece would pick these things up. It would get it all cleaned up somehow, move it over to the next station, hold it in place. Another arm would come down, tack it. Those two pieces would get out of the way, and then another robot arm would come in and weld the entire thing out. So, I mean, you could essentially just load sheet metal and, heavy plate and I-beams on one end, and it's just spitting out fully, ready to go columns out the other side.
Wow, that's incredible.
It's pretty impressive. So I was wondering if you guys had the same thing there where, you're talking about some of these larger complex pieces and everything. Do you have robots to be able to pick things up, move them, set them in place, get them tacked, and then, get ready to weld out?
Sure. We're not currently there yet. I think that's the vision and that's the direction we'd like to move. Currently, we're automating particular pieces of the process or pieces that are a lot of labor, a lot of weld content. And there's a lot of cost savings just from ergonomics too. We have some really big, really complex weldments that, we have to have welders tie off to a fall protection harness to get up on top of this piece of equipment to make some welds that are in tight places. And we're starting to see automation take over some of those welds that are actually making the welder's job safer so that they don't have to get in those weird, awkward, or dangerous positions.
Oh, very cool. So, it's also helping with safety. Ergonomics is huge. I did a tour of a facility down here, and they've got the entire facility set up to where the workers aren't picking up anything really more than probably the weight of their own MIG gun. And they're working on heavy stuff, but the way it's set up with like springs and cantilevers and, pistons and hydraulics and pneumatics and all that stuff, they're just hitting pedals, spinning things, rotating them, moving them. But like I said, you're not picking up any more than 5-6 pounds, and you're not bending over constantly. You're not sitting at weird angles. Everything's, right where you need it to be. You can kind of adjust things where, it's more ergonomic for your body. A lot of people, they don't take that into consideration because we've always done it the hard way just because that's the way, the old timer that showed me how to do this, that's the way he did it. So that's the way we're going to keep doing it. And if it's not broke, we're not going to fix it. But ergonomics play a huge part into the physical lifespan of your body.
Yeah, we at Vermeer, I spend a lot of my time looking at fatigue life of welds out in the service of the field. And we got to spend just as much time looking at the fatigue life of the human body. and how our workers, and especially our skilled labor, highly valuable to the company. You can't just replace somebody who's got 10 or 20 years of welding experience. And how do we protect them and make sure that we're being good stewards of our employees as well, and helping them go home safely at the end of the day and not be one of those welders that's over 50 whose knees hurt all the time.
Yeah,
and
knees are all busted out, arms don't work. Yeah, that whole deal. That's awesome. You guys are taking that into consideration. Now, when you're building this stuff, like, how do you determine which welding process we're going to use? I mean, are you guys pretty big on hardwire, or are you adopting like flux core gas shielded? Because I mean, you're inside, so I mean, wind isn't something you have to worry about. But there's limitations to solid wire where flux core might be a better choice, but then flux core is a little bit dirtier because you get a chip off and clean slag and all that. So, what are some of the considerations you think about when you're designing a welded connection for some of the stuff that you do, whether it's going to be manual or robotic?
Sure. I would say probably 95% of all the welding we do at Vermeer is solid wire GMAW, mostly pulse. We hardly do any just straight CV. It's mostly all pulse GMAW, which really lends itself well to automation. The GMAW process, really great for automating because the torches are small. You've got that continuous wire fed process, so you can weld for a really long time. And as long as you've got enough electrode and you've got enough gas and your robot's running, you're good. You're golden. So there's really high productivity returns with that process. We do have some joint designs that we do some sub-arc on, and we do submerged arc welding. One of the pieces of equipment, it's actually the largest piece of equipment built in the state of Iowa, is a big surface miner. So it's got this giant steel drum with all these teeth attached to it, and it spins at a fairly low RPM, and it's used for mining different types of aggregate. And that main drum is 3-4 inches thick. And so we've got a U-groove, and we do submerged arc welding on it, just because that's a better process for that particular component.
Now, is that a full pen weld, or are you welding it from the inside or welding it from the outside and then back gouging and welding like a sub arc on a track on the inside of it?
It's a CJP with a backing ring, essentially.
Okay.
It's really got like a separate stiffener ring inside of it that we use as a backing that we weld.
So it's like a circumferential weld, not linear?
Yeah.
Okay.
Yeah, it's a circumferential weld. Yeah.
Okay. You get what kind of backing? Are you using like a solid backing or copper backing?
It's a solid backing.
Okay, yeah. So it stays, it lives with the machine once it's done.
It stays with the machine. Yep.
Okay, very cool.
Yeah, it actually becomes like some mounting points for the bearings.
Yeah. There's a place down here, Pemberton, and they build like heavy like front end loader buckets and rock crushers and bulldozer blades and all that stuff. And we went into their shop because I did a lot of shop tours with my students, and they're cutting 3-inch thick steel with a plasma cutter, but then they're taking it over with cranes into a rolling machine. Like if y'all have never seen 3-inch thick steel plate being rolled, it is a work of art. There is a pure science to that.
There definitely is. Rolling really any type of plate is a science. And there's a lot of skilled labor that goes into just metal fabrication. We think of fabricators as welders, but fabricators really are, steel workers who are cutting parts, that are rolling parts and fitting parts together. That's all part of that fabrication process. And that's all a skilled trade job.
Yeah, there's actually a lot of welders out there that can't fabricate, and a lot of fabricators that can't weld. So if you can do both, I mean, you could pretty much write your own ticket wherever you want to go. You can cut, fit, fabricate. That's the one thing I always told my students. I was like, it's great that you learn how to weld, but you've got to learn the other side to it. You got to learn how to put this stuff together, because especially down here in Florida, you have to be able to fabricate and then weld it together. I mean, you're supposed to be a one-person crew, or you're working with a crew of people. But most of the time, you don't have somebody cutting out all the parts and pieces for you, and then you're welding it and connecting it together. Like, I know up north that's kind of big. Like they have everything sectioned due to like the way the union operates. So if you're a welder, like that's what you do. Like all your parts, pieces, everything's cleaned up, prepped, ready to go for you. You just show up there and you weld it out. You got a fitter and all that stuff. But yeah, if you want to be a multifaceted welder, learn how to cut, fit, and fabricate. That is huge, even with robotics, because if you know how to do it manually, then you know exactly, okay, I have to compensate for this weld over here, so I need to notch the corner out in this gusset. I mean, it's going to help you with, designing components as well because you've physically done the work.
Absolutely. And it's kind of funny you mentioned that. Part of my role at Vermeer as a welding engineer is actually to work with our design teams and help them understand better design principles to design weldments to be robotically welded. And we've got a lot of mechanical engineers, we've got a lot of engineers that have been put into a design role that are trying to learn about welding and designing weldments for the first time. And if you've never welded, it's really difficult
It is.
to design a part that's good to be welded. You don't understand weld access and
how am I supposed to get this 300 amp MIG gun inside that little pocket and make that weld? That's not happening.
Yeah, for sure. And we run into a lot of parts that the drawing will show a weld that you can't get to anymore because you've welded other pieces on top of it. And so part of my role is to interface with our design teams and help them understand how to design weldments that are not only just friendly for manual welding, but also for automation so that we can automate more of our processes.
Mm-hmm.
So you got to start with your upstream processes with automation are really critical, whether it's bending or rolling or any of those upstream processes, but also your design process. You got to design parts that are well suited for automation.
Yeah. Now, is that the same thing when you're developing a welding procedure, or can you recycle a lot of your WPSs that you were doing manually and just program that into the robot?
We do a little bit of both. With welding procedures that are designed for manual operators, you kind of run into this tipping point where a manual welder doesn't want to weld at 18 or 20 inches a minute.
Mm-hmm.
They want to weld at 12 or 14. That's comfortable for, especially like an 045 GMAW. That's where they're comfortable at, which is perfectly fine. That's where I'm comfortable at welding manually. When it comes to automating the welding process, we have a lot more freedom because the robot doesn't really care how fast it's going.
Yeah.
And so we use our manual WPSs as a good starting point. But then we also develop purpose-built robotic WPSs that are in the 22, 24, 28 inches a minute travel speed range.
That was going to be my next question, is when you're designing stuff for a robot, now that you have a little bit more, I don't want to say freedom, but you've got a little bit more, you get some more options to choose from as far as travel speed, distance, the amount of wire feed you can throw at something. Heat input, because like you said, if you're doing 12 to 14 inches a minute, your wire feed speed and volts are going to be a little bit lower, but you can get that same heat input running faster with, travel speed with higher voltage, higher wire feed speed. But a human's not going to be able to keep up with that. If you got 200 linear inches a minute or 200 linear inches of weld, a human's not going to be able to keep up with that at that 18 to 20 inches a minute, but a robot can. So now I can start hitting the limits of what that wire is capable of carrying.
Yeah, absolutely. And a lot of times we also see we can step up in wire diameter. A lot of what we do is 045 or 052 solid wire. When you start automating processes, it's not uncommon for us to start with 16th wire. And manually welding, running 16th solid wire is a tough thing to do for a manual welder. It's got a little steeper learning curve. It's a lot hotter. It's got a big puddle. It's a little more uncontrollable. When it comes to automated processes, because we have such fine control over travel speed and volts and contact tip to work distance, we can step up to that larger diameter wire, get that higher deposition rate and higher productivity gains and the robot doesn't care.
Really pour the coals to it.
Yeah.
No, that's really cool. Yeah, because I would imagine that would open up a lot more doors as far as like production wise. Trying to put something in. Like, I mean, because as well as I do, heat input is a huge factor, and the biggest factor with heat input is travel speed.
Yeah, absolutely. And at Vermeer, we build a lot of equipment that's taken a lot of abuse. I've been to some of our customer job sites, and our customers are not easy on the equipment that we build. And so we're constantly looking for, newer high strength, low alloy steels. We're implementing a lot of, wear resistant steel. So we're doing a lot with, some Hardox 400, Hardox 500, doing a lot with A514. And when you're welding those steels, you have to be a lot more careful of heat input and a lot more diligent with your process controls. And through automation, we're able to utilize some of those newer materials without concerns of, production not following their WPS or, doing something we don't necessarily want them to do.
Now, with those different alloys and stuff that you're working with, are they requiring like pre and post weld heat treatment?
We do a little bit of post weld heat treatment. We do quite a bit of preheat. We also do a lot of work with some of the 4140s and 4340s that you have some concern of hydrogen cracking and delayed cracking. So we do a lot of preheat with those. A lot of work with induction preheat.
Okay,
which is really cool. We kind of implemented some induction preheat as one of those processes to really take fatigue off of the welders. It's not fun when it's today it was 98 degrees here in central Iowa, and you're inside a metal building with a huge torch trying to preheat this part. That's really taxing on the welder. And if we could have induction heating where the welder can put that part on an induction coil and walk away for a couple of minutes and come back and be ready to weld, it's a win-win.
Yeah, I was wondering how you guys did all that. If you kind of automated your pre and post weld heat treatment because you're working on such big sections, or if it's all done through induction, because I mean that's a labor intensive process in itself to be able to get the coils exactly where they need to be and get everything lined out. I know they're making it a lot easier, but some of the coils and stuff, like they kind of like an endless loop. So you got to line it up exactly, where you're going to be needing it.
Yeah, you're exactly right there. Induction heating's really a neat technology.
It's super cool
because it's just a magnetic field.
It's almost
right?
instantaneous.
A magnetic field to heat up these parts, and we've played around with induction heating on a lot of different parts, a lot of different shapes. We have some custom induction coils made for heating very specific parts and in very specific places. Because you may have a part, that's the size of a room in your house, but you only need to heat a very small, 2-foot section of it, because that's where you're welding some really critical pieces to. You don't need to heat that entire part. And induction heating allows you to do that really efficiently.
Mm-hmm. Now, when you're welding a lot of the stuff out, are you using different modes of metal transfer with this, or is it pretty much all spray or pulse spray?
It's pretty much all pulse spray.
Even in like the flat position?
Yep, even in the flat position. Really? We found that it's a little easier for us to control just the manufacturing process instead of trying to switch to like a straight CV spray or something like that.
Okay, so you're getting better results actually incorporating pulse and essentially in position.
Better results and just less changes on the welders. The welders don't have to go over and change to a different mode or a different program on the power source. They can just adjust wire feed speed and their voltage or arc control and keep going.
Okay. Now, do you guys have like what they call, I guess it's pretty standard across the industry, vision technology, where cameras are actually mounted to the torch or to the arm of the robot, so they can do, they can identify the part, but I guess they can also do somewhat of seam tracking throughout the piece. I know there's an additional software for an upgrade, of course, to do seam tracking through voltage.
Yeah. So there's a lot of really neat technologies in robotics to account for part fit up and part variation. So the first one you talked about is through the arc seam tracking, which uses basically a voltage or an amperage reading as the robot is weaving through the joint. So it's tracking that feedback of voltage or amperage through the arc, and through your welding procedure process, you kind of know what your nominal settings are supposed to be. So you can set that in the robot controller and it will monitor that as it's welding. And that's how it kind of finds itself in the joint and continues tracking that joint as it's welding. The other technology you talked about is vision systems, or you know, there's a lot of different options with vision systems, and you can get everything from, there's a company in Ohio doing AI assisted vision and programming where they're actually using some really complicated, really high tech cameras to scan the part and using an AI program to teach the path. So you really have to do no manual programming of the actual part. The robot does it all. It scans the part, generates the path based on where you've told it the welds need to be, and it will weld that part. It's like a custom program for that part. But then there's also more, kind of simple vision systems of part identification or a laser that just comes down and it scans the weld joint. It's looking for a particular profile of that weld joint, and it just uses a simple offset to adjust for where the part actually is in space.
Oh, that's pretty neat. Yeah, that was actually going to be one of my other questions, was because I read, I didn't read an article. I seen something the other day that was talking about incorporating AI technology into robotic welding and additive manufacturing. So I was wondering, how are they? I mean, I'm only familiar with like Chat GPT, so like, if I got to write an essay or something, like I can, have that thing walk me through. But how are they using that to program robots, or how are they using that in automation to make life a little bit easier? How do they incorporate artificial intelligence into automation?
Sure, I'll keep it really high level because I'm a welding nerd and not an AI expert by any stretch of the imagination. But kind of like I just talked about, they're using some of these vision systems to, scan the part in real time and compare it back to that 3D CAD model. And it's able to not only just search the joint in 2D space, but actually find the entire part in 3D space. And based on the information you've given the controller about these are the welds and this is the weld size, it's able to take that different joint configuration and create custom welding parameters to, say you want a 3/8 fillet weld. It's able to look at that joint fit up, create custom welding parameters to give you a 3/8 fillet weld exactly where you want that weld in the joint. Maybe you've got an intermittent fillet weld laid out. It's able to calculate all that, and really some neat technology.
It is very neat technology. But so, like, I was never afraid of robots taking welders' jobs and stuff until we're slowly starting to incorporate AI. That part kind of scares me.
AI is another one of those technologies that's kind of, I would say, upset not just the welding world, but upset everything in life. And I think their AI has its place, and we're gonna see, AI helping take away some of those really kind of medial tasks that we do every day. But there's always going to be somebody that has to do maintenance on a robot, or understand how that AI works. And so there's always going to be room in the marketplace for those types of jobs. And
yeah,
it's kind of funny, people who don't know what they want to do at work, or get tired of what they're doing at work, they ask me, Sam, what should I become the expert in? And I always tell them either to go into welding or to become their company's AI expert, because there's going to need to be somebody who has to fill that role, and it might as well be them.
Yeah, that's kind of the direction I'm pushing my son in, to get into robotics. because he's got to choose like different electives at school for next year. So I was like, man, look at robotics. Look into robotics, because no matter what happens, you're always going to be able to find a job in that field, whether it's pharmaceutical, food service, welding, engineering, like anything. Everybody's going to be using robots for pretty much every occupation. So if you can get in there, especially like a robotic technician, for where you can bounce from one industry to the next, but the technology is still the same, because I mean, it's very similar to a welding machine. If you can repair a welding machine, doesn't matter what color the machine is, you can pretty much work on it and diagnose it. Same thing with a robot. Whether it's yellow, blue, green, doesn't matter. The science behind it it's still going to be relatively the same.
Yeah, I totally agree. And robotics it's a growing field. I mean, robotics is exploding right now, partly because of the cobot movement, but also because, like I said, these companies that, like Vermeer maybe have shied away from automation in the past are realizing that robotics and automation is the future. That's how they're going to grow. Here in rural Iowa, I don't live in a huge city. I live in a city of 10,000 people, and we're competing with other employers in the area for that same labor shed. And in order for us to grow as a business, we have to do more with less people.
Mm-hmm.
And we have to give the tools like automation to empower our employees to be able to be more productive and do more work. And more companies and specifically some of those legacy companies are seeing that that's the future, and that there's a huge explosion of demand in that market right now. Just welding robots, we're looking at 30 to 40, and sometimes in cases even 50 or more week lead times. I mean, a 56-week lead time is a year.
Mm-hmm.
And that's a really long time to be thinking about automation and trying to plan automation initiatives.
Yeah, you got to start dropping off little cobots and stuff at the local Votech school. They're dropping one off in the welding shop there.
For sure.
You'll create a steady pipeline.
I think cobots are great for welding schools as well, because they help those welding schools are trying to respond to this growing need for robotic technicians and robot welders, and they're looking at how do we meet that market demand of these employers coming to the school saying, hey, we're looking for robot technicians or welders that know about robotics. And cobots also allow the schools that really great entry level point to get a robot and integrate it into their curriculum.
Mm-hmm.
And you can have somebody who's been teaching welding for a long time learn how the cobot works and be able to develop curriculum off of it. And I think we're going to see the ease of programming that cobots have very rapidly expand to traditional robot cells.
Yeah, and there's a lot of grants that are available for robots, cobots, CNC plasma cutters, and all that for the different schools that are out there. So I didn't realize it, but a lot of the big box stores and department stores, they provide grants as well. And it's because at the end of the day, the consumer or the worker is going to shop at their store at some point or another. So they want to point people into the general direction of working with your hands and working with tools. And hey, if we donate $50,000, $60,000 to a school and they can afford a cobot, they're going to train welders, or they're going to train, whatever. They're going to train, a skilled trades worker. That skilled trades worker is going to get into the trade. They're going to need tools. So that they're going to come stop by our store, on the weekends and stuff for DIY projects or, tools for the toolbox at the shop and everything. So there's a lot of grants and scholarships that are out there to be able to start getting this technology into your high schools, your technical schools, your colleges, all that stuff.
Yeah, for sure. I think there's going to be continuing to be a growing need for that skilled trades position, whether it's welding or CNC machinist, and those positions are not going away. In fact, the number of empty positions is growing. I think AWS for a really long time published the number of 525,000 open positions by 2024. I'm sure that number has grown. I think that's an old statistic. And, we keep seeing people retiring and people not going to the skilled trades. I think the most recent one I saw was that 40 to 50% of skilled tradesmen are going to be retiring in the next 5 years.
Yes,
and that's
Andrew Brown was
really
talking about that. I was like, I didn't realize it was, when you put it into percentage perspectives, yeah, it's easy for you to say. When you put it into percentage perspectives, it's very, I mean, it's blatantly, I didn't realize how obvious it was, but 40 to 50%.
It's almost a scary number to think about.
It is.
You know, and I work specifically in manufacturing, but somebody's got to build bridges and airplanes and infrastructure. Right. And, you know, when the plumbing in my house goes out, I want to be able to call somebody, and it's not going to be very long before we have very long lead times for, you know, those types of calls, or really struggle to get skilled trades. You know, we're not going to be able to build new bridges because there won't be people to build them.
Yeah, there was one of the organizations that I volunteer with, the power went out at their facility the other day, and they're like, well, it's either the electrical panel on the building or the meter out front. And if it's the meter out front, there's a 13-month wait list. I was like, you got to be kidding me. It's a 13-month wait list just to be able to get a new meter for the front of an industrial building. Wow. So it would literally shut that business down for an entire year before they could just get power back to the building. Luckily, it was the panel. Everything got fixed, so it was all good. But yeah, I went ahead and pulled up the welding workforce data. That AWS has been doing a really good job of keeping that updated. There's 360,000 professional welders projected by the need by 2027. So in just 4 short years, we need 360,000 people, roughly 90,000 people per year.
That's incredible.
That's scary.
That is scary.
But when you throw it into a percentage, it's a lot scarier. You're like 50%.
It is, but I think that number also goes to show just how much opportunity there is in our career field. You know, welders should be a highly respected career field, and you know, welders, they are the ones that take steel and build buildings and bridges. They're the backbone of America, and I think it's really exciting to me to see that there's that much opportunity in the career field that I work in and the career field that I love. I love welding. I love the art and science of welding. And it's really exciting to help young people get into that field and know that there's that much opportunity available to them.
Yeah. The great thing is the perception's starting to change. I see a big shift in the perception of welding and skilled trades in general. You know, especially when I was speaking with parents coming into the program and stuff, they were dragging their kids there. They're like, hey, look, I know there's a lot of opportunity in the skilled trades. I think my son or daughter would do great in the welding field. And they bring them by and, you know, check it out, and the kids get interested in it. You know, once they see that little arc, there's just something about playing with fire that kind of pulls you. I mean, look at, you know, your situation, mine too. Like, that's when I got into welding, was my sophomore year of high school. I was like 14 or 15. I watched my dad cut a piece of chain. The following year, I signed up for a welding program. That was 25 years ago. I've been having a blast ever since.
Yeah, I mean, when I first started welding in the back of that, you know, welding supply store, you know, with a 7018 stick electrode, melting 2 pieces of steel together, I mean, I was like a kid in a candy store. I was like, this is awesome. You know, it was probably the first time in my life that, you know, really I got to do something super dangerous. And, you know, it was fun, and it was really amazing, and that's what really started the passion for welding for me, and has led to a really awesome and really fulfilling career.
Yeah, I was going to say, it launched you down a path to an awesome career. I would imagine it's relatively lucrative. I mean, you seem genuinely interested in it, excited. I mean, you volunteer to do more outside of what your requirements are at the job. I mean, you're involved with the IIW and AWS and all that stuff. So, I mean, yeah, I mean, you're definitely passionate about it, but welding seems to have that effect on people.
It does, and it amazes me the different people I meet from the welding community that come from such a diverse background and so many different paths. You know, It's kind of funny. I used to tell people when they asked me how I got into welding that I took a non-traditional route to welding. And then I realized everybody has a non-traditional route to welding. There's no real traditional way to get into welding. It just sort of seems to draw people from all walks of life, from all different, avenues. I've met, people in welding classes that I've helped teach that were police officers or bankers before, and there's just something about welding that attracts them as a new career or a hobby, or just something they want to learn because they farm part time and they need to be able to fix something that breaks out in the field.
Yeah.
It's really fun to meet all these different people in the welding community and who have such a diverse background.
Yeah, I get the question all the time. They're like, "Yeah, I'm 60 years old. Is it too late for me to get into welding?" No, I taught a guy who was 65 and wanted to start working on his second career. And I asked him, I was like, "Brad, why are you in this program? Like, you've been, you just retired from glazing windows for the past 20 some odd years." He's like, "Tired of working with windows, but I'm not ready to retire yet, so I need to find another career." Okay, cool. And I mean, he made an awesome welder. He did great, and he had a passion for it. So it's never too late to find that spark.
Yeah, I totally agree.
Yeah. So now you're going to be talking over at the Welding Automation Expo and Conference that's taking place in Columbus, Ohio, October 10th to the 12th. What's your session going to be about?
Yeah, so my session, it's actually the first session of the conference, so I get the honor of kind of opening up that
no pressure
conference. It's really going to be kind of an anecdotal session on legacy companies like Vermeer and other companies that are large companies in our kind of market space, our path to automation and some of the lessons we've learned as we've implemented automation, from that kind of, I call it the legacy company point of view of a well-established company, and what, some of the mistakes we've made as we've gone into automation because, we're a big company and we think we know everything, and how we can help kind of rethink automation and how automation can help our businesses and how we can pass some of those lessons on to other companies that are looking at automation and wondering, how do I get into that? Automation can be scary at first, as, people see automation kind of through the lens of automotive, and they see a factory that's fully automated and has hundreds or thousands of robots, and kind of helping shift the perspective on how to get into automation.
Okay. Now, would you say you guys are on like the leading edge of manufacturing or the bleeding edge? And a lot of people don't understand that term, but like staying on the leading edge is like staying up to date with technology. Being on the bleeding edge is kind of spearheading that whole campaign or that movement into something. And they call it the bleeding edge because you're absorbing all the mistakes. You're going through all the trial and error. You're screwing things up. You're spending buku bucks to try and figure out how to make this stuff work. So are you guys, you consider yourselves on the leading edge or the bleeding edge of automation?
I think in general, Vermeer's probably on the leading edge. We are really focused on new technology and where it's going. But we also have a really fun space for R&D, where we get some money that the company sets aside and we get to just have fun with it. And if it works out, great, we may make the company $1 billion. And if it doesn't work out, well, we might lose the company $1 billion. And that's okay, because when it does work, we get to be on that cutting edge and really get the gains and the productivity improvement from it.
So they kind of budget for anticipated failure, but if it does work out, the stocks are going to go up.
I think the desire is that it always works out.
Oh yeah, I mean that's the goal. But I mean they earmark some money just in case if this doesn't work out. We're really not out anything. We'll try again next year.
For sure. We have a really great R&D team, and I get to be a part of that research and development side. An example of that is some laser welding. Handheld laser welding is something that's really new to the welding market, and we've been fortunate enough to get to just play around with lasers and find the right applications and quite a few of the wrong applications for laser welding, and see how that can, either help or hinder our manufacturing environment. And, we've got some really good use cases where it works, and we have some other use cases that we tried and it failed pretty miserably. Okay. But we learned lessons, and that's the fun of being an engineer is right. is getting to learn those lessons.
You don't have to
grow
up.
A lot of trial and error. Yeah.
No, that's really cool. That's one thing I've always wanted to play around with. I have not messed with the handheld lasers yet, and I see it on social media all the time, and I'm like, man, that's really cool. I kind of want to do a fillet weld brake test on that, or I want to do a cut and etch. I want to see what kind of penetration profile we're getting with this stuff.
My favorite videos are the ones where you see them doing it, but they're wearing like flip-flops or something. And, those kind of get me on edge a little bit. But it's a really neat technology. And, we've seen automated laser welding take off in a lot of industries. And I think it's kind of interesting that we started with automated laser welding, and now we're coming back almost full circle the other way to handheld laser welding.
To manual, yeah. Yeah, no, that is crazy. Well, Sam, before we get out of here, why don't you tell everybody where they can find you? I know you're pretty big on LinkedIn. I don't know if you have any other social media outlets you want to plug.
LinkedIn's the main one. I'm pretty active on LinkedIn, so feel free to connect with me. It's Sammuel Chance, CWI/CWE on LinkedIn. And then my email address is also samuelchance@vermeer.com.
Well, awesome. I appreciate you taking the time to come out here and chat with everybody for Weld Wednesday. I'm really looking forward to attending the automation conference. I'll be up there, so hopefully I'm there. I should be there the first day, so I'll go in there and pop in and check out your session.
Awesome. Well, thanks, Jason. I really appreciate the invite to be on the podcast. This has been really fun. I'd love to come back sometime, and look forward to meeting you in person in October.
Oh, definitely. I'll see you out there.
Awesome.
All right, ladies and gentlemen, thank you so much for listening. I hope you all enjoyed this month's installment of Weld Wednesdays with AWS. For more information on the upcoming automation conference, as well as other AWS conferences and seminars, head on over to aws.org/conferences. For more information on becoming an AWS member or how you can get involved at your local section, hit up the AWS homepage at aws.org. Be sure to tune in the first Wednesday of every month for new episodes of Weld Wednesdays with AWS. Hope you all have a great rest of your week. Stay safe out there, and until next time, make every weld better than your last.